Hey everyone, we're going to use the principle of mathematical induction to prove that 7 to the nth power plus 5 is divisible by 6 for all positive integers n. And we're going to use these steps and use our definition of divisibility to rewrite our conjecture. This is not a sum. We're using this as conjecture. Is 7 to the nth power plus 5 equals 6r. That's based off your divisibility definitions. So now we want to verify for step 1 that it works for n equals 1. So if we verify this, we get 7 to the first power plus 5 equals 12. And since 12 equals, and we're looking at this, 6 times 2, then it's valid for n equals 1. So that works. So now we're going to try, and we're going to assume that it's true for s sub k. So we're going to write this again, and we're going to write 7 to the k power plus 5 equals 6 times r, and r is an integer. It's for some r. I'll just write it like that. For some r that's an integer. And now we're going to prove, in other words, that this follows s sub k plus 1, all the next terms. So 7 to the k plus 1 plus 5 equals 6t, and we need to have a different term here because it's going to be different than this one. And our t, for some t, that's an integer. All right. And what we're going to do is we're going to make this one look like this. So we're going to start with this part here. So we have s sub k equals 7 to the k plus 5, and that equals 6r. And again, the r is our integer, and we want it to look like this one. So we're going to make this one look like this one, and this t is an integer. All right. So the way we're going to do it is we're going to multiply both sides through by 7. So we take this original one and multiply everything through by 7. So we can do 7 So I multiply both sides by 7. Now this one, when you multiply these two, this is going to be 7 to the 1 plus k, or I can put the k plus 1, plus 35 equals 7. So this is just going to be 42r. All right, now I want to make this look like this one here. So I need a 5 here. So what I'm going to do is subtract 30 from both sides. So put a 30 here, and you get 7 to the k plus 1 power plus 5, now we have it, equals 42r minus 30. So I've got the first part right. Now we need the 6t. So I'm going to write this down again. I want to factor out a 6. So factor out a 6, and you're going to get 7r minus 5. And we're going to let t equal 7r minus 5. Now you know why we switched up the r's and the t's here. So when I rewrite this, you get 7 to the k plus 1 plus 5 equals 6t. And it achieved our goal. We have this here. So we have shown that since s sub n is valid for n equals 1, it is also valid for n equals 2 and n equals 3 and so forth indefinitely. So it's divisible by 6 for all integral values of n. And that's it. Thank you. Have a nice day. Bye bye.